Hello live coders, I'm Mr. Reason and today I show you how to record your input and output audio signals in TidalCycles with the TidaLooper. In the first section of this video I will guide you through the setup and I will show you how to access and read the documentation. In the second part of this video I will provide you some examples and techniques. Let's start with the setup. The release can be found on GitHub. For this, you can go through github.com/thgrund/tidal-looper. But I put that link below in the description section as well. So the first thing is that here you find the README with a detailed explanation how to set up everything, the pre-requirements and how to use it. Of course, a big part of this video will be exactly that I show you how to set up everything and how to use it. But in any case, you find everything here in the README as well. And for some Tidal-specific code examples, you can go through the subdirectory Tidal. And here you have mainly the examples that I will show you as well. So on the right side, you find the releases section. When you click on the version and the latest version, you can simply download the zip file that is here in the appendix, whatever. So you find the assets here. You can simply download it and then unpack it. And basically, that's done from the GitHub site. Then you can go to Super Collider. Here I just use a real basic setup, so nothing special. This is the Super Collider IDE that you should have already installed when you already use TidalCycles. So in the quarks list, you can install and find your plugins or quarks, the so-called quarks. In my case, I already have the TidaLooper installed. If you have an TidaLooper quark already installed and you want to reinstall it, you can simply uncheck it and then click on install folder or install a folder. And here you can then just select that folder, open it, and then it will appear here in the list. You can rename that. Quark. It doesn't matter. The only thing that matters is you should not have two TidaLooper versions in parallel. So I uncheck it, but when you installed it, in that way you can then trigger recompile class library. And then you can access these lines of codes that I provided here. So when I execute TidaLooper equals TidaLooper with the dot instance as a parameter, then you should see something like this in your post window. So the TidaLooper starts the initialization and that these functions were successfully loaded, like OLooper, persist looper, loops, slooper, looper, and rlooper. For this example or this tutorial, I use these parameters. And a lot of these parameters that you can set in Super Collider can be modified in TidalCycles as well. So you can consider these as the default values, while everything that you override on the TidalCycles side has then the precedence, so the higher priority. Okay, so in the end, for my examples, I want to have a low latency. I want to mainly record the input audio signal as a default, and I enable the debug mode. When we go to the startup SCD, so this is my messy startup file, then we have this line that I can highly recommend, because when you use something like this, it's my old audio interface. I use a Focusrite audio interface right now while I'm recording that. But this enables you to record audio signals with low latency. This is just my PreSonus audio box. And you can control the hardware buffer size with this command. So besides the latency, with this value, you can control how much computational power it costs to record something, and of course it affects the latency as well. Then in this section, in-device, out-device, you specify what audio device you want to use, and you see for my input device, I use my audio interface, and the out device is black hole because I route exactly this audio stream that will be produced to a DAW. So just for convenience purposes. And then I have every orbit in TidalCycles routed to my output 0 and 1. And with that, you see that my input signal can be seen in inputs 1. So these numbers are, especially on the input side, are important because we can then specify what input source we want to record on the TidalCycle side. The outputs doesn't really matter because when we record the output, we directly access the audio stream within TidalCycles, or the so-called orbits. All right. And last but not least, when you hover over TidaLooper and you press Alt or Command D, then you open the Super Collider related documentation that you can see here on the right side with all the class methods and examples and description. You can explore it, play around with it, especially when it comes to the record level and the P level. It highly depends on your setup. So yeah, feel free to have a look here. Now let's move on with the TidalCycle side. First of all, I execute these lines of codes: the tick, name, L input, and record source. This will provide us some more control over the looper. When you use an editor that supports event highlighting like NeoVim or the Pulsar editor, then you can create this visual feedback with the tick function. It is doing nothing but visualizing the pulse of the current session. And I will start with recording the input audio signal. For this, we use a single shot looper. This looper mode is really useful when you have no special equipment and you actually do live coding with the keyboard only and instruments. Because whenever the S looper got triggered and it has no written buffer, then it will be executed and write audio signals to the buffer. But if there is buffer already available, then the S looper is not doing anything and you need to free the loops manually. For example, you see that the S looper got triggered, and now I can free the loop and control with one command that I free the loop, and when the S looper got triggered again, this provides us a rhythmic foundation that I can use in a pattern. So let's execute the tick function again, because now I want to create some kind of synth-like sounds that can then be used in a backing track. And now let's see the result. Okay, so let me explain these patterns more in detail. As I said, free loops actually freeze the loops. You specify the L name. This is the name of the sample bank. And with N, you specify the position within the sample bank, what you want to delete, free, or whatever. In this case, I want to free all the recorded drum sounds. And for this, I reserved 4 patterns. So when we look into that pattern, then you see the L name is drums. And with N, I specify the position within the sample bank, yeah, but the length of the pattern specifies the length of the buffer. And with L input, I choose the first the input number 1 of my audio interface, and this is exactly what you saw on Super Collider. And I said that the number or the length of a pattern specifies the length of a buffer. And this is the case for D1 here with the synth pattern as well. I slowed down the pattern and now this buffer is twice as long as the other buffers. And as you heard, I use a reference tone, or I used just one note to create all the other notes or sounds. And for this I use C, because then everything is harmoniously in the pattern. Okay. Now I show you some examples where I record the output. For this, you specify the record source out, and the L input, the default L input value is 0, which means that I record the orbit 0. In this case, I record D1. Replace looper means I record the audio signal, and whenever I trigger the looper again, I replace whatever was in the buffer. When I change the pattern, for example, then you hear that every time the looper got triggered, the buffer of the loop completely got replaced by what was produced by the original pattern. And there is a third mode, it's the overdub mode. Basically, that whenever the looper got triggered, on the same buffer, I stack the audio result on top of that buffer, so everything is stick together. The next example is a little bit silly, but it's really interesting. You can access the buffer or the loop while you write to the buffer. And with this, you can create, for example, a canon-like structure. Okay, I think I imagine that you can do really interesting things with that. But anyway, the next example is where I record different loops, but I manipulate them with the same pattern. And now we start from the beginning. On the other hand, you can record the same loop and then manipulate it with different variations of a pattern. Like that. And last but not least, another interesting technique is that you can create feedback loops with the TidaLooper. So it means that here the replace looper records on buffer 0, then on buffer 1, but we play back buffer 1 and then buffer 0. So it means that we record something, we play it back, and then we record the manipulated buffer again, and this happens in a loop. You have the option to create a feedback loop that can be restored technically. Like in that case, we shift just the slice by one part, and then at some point the original pattern and the manipulated pattern will match again. Okay, and the last example is a feedback loop with the end condition, because you can create patterns that cannot be restored. Like in that case, I slow down the result more and more, and it will never be restored. With this approach, I recommend to have an end condition, like in that case, after 7 repetitions, I record the original pattern again, so that you can then access this feedback loop or reset the feedback loop. And that's it. If you like this kind of content, feel free to subscribe and put a comment below. I read everything and reply as soon as possible. That said, keep coding.